guest tonight is Bob Heil. Bob, we're all eager to hear about antennas this month.
Yeah, you would think I'd be talking about something else, but hey, I love antennas. I really do. And all my life, I've been playing with antennas and still doing it. And we're going to get into some things. I hope things that will help you a little bit. And one of the things I do hope is that we don't start out like this. I only hope that was a Photoshop. I really do, because yeah, somebody was a little bit crazy when they did that, I imagine. But safety is really important when we're doing antennas. Very, very. Always the best question. What is the best simple antenna? We're not talking about 150 feet tower. We're talking about the simple antenna that will work. And there is nothing that will equal a resonant dipole. And you can play all kinds of games with those. You can add some traps and get other bands. I like to do this. You can make a really nice 3-band fan dipole and just quarter waves from the balun out on each one of the bands that you want. And that works really good, really good. Some try to go with 7 and 8 and 10. And no. The problem with that is that they get tangled up, but you can handle a 3-band really nicely, and it works terrific. How long do you make it? I hope that all of you know this. It's 468 divided by the frequency. And you always want to use a balun. One of my favorite subjects is about the balun. And we'll get back into that in a minute. Let's talk about antenna height. Higher is not always better. And I always thought so. Gosh, in my early days, I had up a 110-foot roan, 128 elements on 2 meters, and another tower with a 36-foot long Telerex 6-meter wide spaced. I was a very serious VHFer. I was a technician for 17 years, because when I got into this great institution, it was 1956. It was the start of the largest sunspot cycle. And there was no reason to go anywhere else. It was nothing like we have today. 6 meters today is a ghost land, and it's nothing like we had then. 6 meters was open 24/7 just about, and it was really fun. And I had big antennas and a lot of power and all that kind of good stuff. But then one day I read this. The optimum height for a dipole, it's been the subject of many conjecture and good arguments on the airwaves. A publication that I read from Art Collins stated most transmitting antennas, notice he says of resonant dimensions, elevated a quarter wave above the ground or as close to 100% efficiency as possible. And when I wait a minute, if I had a 100-foot tower, isn't that where I put it? No, depends on the band you're using. Here's why. A transmitted signal is the resultant of 2, not 1. The one you see, of course, you figure, but there's a direct way underneath. It's reflected from the ground. The reflected ray travels further by the distance of B and C. Your job is to get that reflected image to meet with the direct ray, and you do that by the height of the antenna. I did a study when I first got, as I said, I was a technician for 17 years. Then I got on the road with all the musical things we did and microphones and all that. I was off the air for 12 years. And when I came back, I got an extra class. I figured 6 meters was a ghost land. It was it was nothing. And all it is the contest band. What's your grid square? What's your grid square? I don't have a grid square. What's your grid square? And once you tell that to them, they're gone. Wait a minute. What kind of transmitter? What kind of antenna? They don't want to talk to you. They just want your damn grid square. And it's really sad what's happened. Now it's all FT8. So sorry. So I got in 1976, got my extra class, and I met up with some really neat guys on 40 meters. And I thought we would bear this out. And so we did. What we did, I took one of the towers, took all the antennas off, and we started out one night. First I had a reference antenna. I put a 40-meter dipole resonant. I put it up about 20 feet or something like that. And every night I would come on with a different antenna height. We had a guy in Florida, had a guy in California. We had a guy at the comm center at Collins, and we had a guy in Parma, Ohio. And we'd come out with that reference antenna. And then I started in. The first night I went to 20 feet. Nothing more. Then I jumped up to 40 feet. I missed the 33. I jumped up to 40 feet. Okay. And it was a little bit better. But then I came back to 33 feet and somebody asked me if I turned my amplifier on. You see, we got those two signals together. We were able to get the reflected wave and the solid ray that you see, and it does work. So then I went back, and next night we went to 40 feet. That didn't do much. The next night was, 50 feet's got to do it, Heil. It really didn't. But the next night, I went to 66 feet, and it was overwhelming. And so these are things that we never get to hear about. And yet they really, really are something special. And I don't understand why we're not hearing or reading more about that, because it's definitely part of the science. And trying to get these guys to listen to us, no, they got their own conjuncture. Well, hey, I'm going to listen to Art Collins, which I did for years. I'm sorry he's gone. And there's just all kinds of antennas you can do, again, using the dipole. A lot of times you don't have supports for them. Use a messenger line. I use 5/8 black Dacron rope. This stuff, I've got some that's been up for 15 years. It does not disintegrate. It's really good. And don't get that quarter inch. Get you some 5/8 or half. Yeah, it's heavy, but boy, I never have any problems with it. And you can do slopers off of your tower. But then you can get directivity with phased array wire dipoles. What are you talking about? I can get really good stuff. I don't have to buy a beam and rotor and all that, because you see, two signals out of phase cancel. And we have to learn how to make a wire dipole have directivity. And it's all about phasing. And again, you don't read much about it. I always thought it was something that only Tim Duffy and some of the big contest stations would deal with. And you can deal it right in your backyard. And I did. I have a little demonstration that you won't forget. I'm going to unplug this microphone. Okay. I have two microphones. They're exactly alike, painted a different color because we have a custom shop. We can do all that. These are PR22s, a microphone that Paul Rogers from Bad Company asked me to build for him. They're very articulate. There is no equalization. And yet, listen, all the F and the S and the P and the B, it's all there. And we could get into some of that, but we're going to stick with the antenna right now. But I got this magic little plug, and I'm going to plug it in here to this microphone. Okay. Now we have two like microphones, only this one's out of phase. Pin 2 is hooked to 3 and 3 is hooked to 2. It's out of phase. Well, big deal, Heil sounds just fine. It sounds exactly like this one. This is in phase. When I speak in it, the diaphragm goes down. This is out of phase. When I'm speaking, the diaphragm's coming up. What happens? This is very important for you to take away from here. What happens when you take two signals out of phase? Oh, they're still working together. And like some idiot piles up on your frequency and you hit the notch button and he's gone. How does that work? It takes his signal out of phase, gone. We could be here all night on my favorite subject. Let me unplug. I think we covered some of that when I was here before, because I really love phasing. There's so much about it that's not talked about. But one of the things about it is it has a lot to do with directivity. This is a tremendous demonstration. It's about 3.5, 4 minutes long. Take notes, pay attention. This is where it all hits the road. And that's what we need to do. Learn about it.
We've just installed some new antennas here at the Heil Sound Station Lab. We use them to test our headphones and microphones. Of course, the best way to do that is get on the air. And we do that using phased array. These are wire dipoles in and out of phase, so we can get some marvelous front to back with simple wires. We'll share some of this technology with you. Using a balloon, I'm going to show you some of the different patterns of antennas. This is an omnidirectional pattern that you get from an omnidirectional antenna, a quarter wave spike on 2 meters or just a plain vertical. This is what happens with that particular antenna. It's equal everywhere. Next is the dipole. A wire dipole antenna mounted north and south will have most of its energy on the east and west side of that wire. It's a wonderful antenna, works extremely well. We have many dipoles here, but we've done a few improvements. By adding a second dipole, a delay line, and a remote switch, you're able to cause one of those dipoles to become a driven element with the second one a reflector, or reverse that switch, and you can guide your signal the other way. And as you see from the pattern on the balloon, you get much more energy, of course, in the driven element side, and the reflector reducing what you hear from the back. Here's a diagram of the system. The two dipoles are 64 foot apart. They're fed with 126 foot of down lead, and these two down leads are connected together with a 43 foot delay line. By the use of the remote relay, we can choose either the east or the west. And as you can see, if you choose the east, the west is delayed by that 43 foot phasing line, thus causing the signal to be directed either to the east or the west coast. The 75-meter array is mounted on a pair of 55-foot telephone poles, 10-foot mast, and 5-foot fiberglass on top. They're in inverted V fashion. They must be exactly 64 foot apart and the same height to achieve maximum performance. Let's take a listen to some of this great performance. This will be a station that is east of me, and pay attention when I switch the box from east to west. And we're
in 1.0 VUW, I'm going to need to go up on the hill and swing that log around to the hut. Because you rounds were off the back, apparently. I thought I'd.
Here's a signal that's much weaker, and you'll note when we switch east to west, we can't even hear him when we're pointed west. He is east of us. The key to the system is the phasing line, the delay line that allows us to select either east or west direction of the dipoles. The down lead that connects the coaxial dipole to the relay system must be equal, each of 126 foot. So you have 126 foot each there, and then you have the delay line. So what do you do with all that coax? You roll it up, put it in a container, and you bury it. Inside the box is the remote relay and the extra length of downline and delay line. This is all about 500 feet from the station. We bury all the coaxes down to there and a rotor cable, as you can see, that controls the relays. We're only using 2 of them because we're just going east and west. 10 amp relays. And as you heard, the system works very well. So what's next? A 40-meter phased array, of course.
Jerry, and you give it to Virgil, and then Bob after that, CAB. I need to do that too. That'd be nice to have. And I was got much to you too about.
Oh, we've had some great times with the coaxial dipoles in a phased array, but you can do all kinds of other things. And this is something that I really had a lot of fun with. And we did, of course, as you saw there, and it's really quite simple when you think about it. I went to the telephone exchange, and they gave me those poles. See, they have a lot of poles that get rotted off, and they just cut them off and lay them in down in the fields. But if you ask them, a lot of times they love to let you have them. And that's what I did here. And it worked really good. I did several of them. I went and got them, and they work great. But it's kind of hard to see here, but this is after I had 75 on the top. I went down to 33 feet. Why did I go to 33 feet on 40 meters? Hello. I think we just learned that. The 65 feet to 64 up there, the water wave on 75, I went down here to 33, and man, did that thing work. Oh man, on 40 meters, it was amazing. But a good friend of mine, K9EID, he had a very small lot in Ohio, and he worked a lot of DX, but he didn't have room for a boom or any of that. So this is what he did. He did it, put a varnished piece of 2x4 on top of his tower, 18 foot apart, and did a phased array, and it worked really good. He was just loving it because he couldn't have any big antennas in their neighborhood, so he took care of it. You can really do nice things with verticals, same deal. And again, with the switching, and you don't always have to have the remote switches, although I was 500 feet from it, so that's why I did that. But you could do it with a regular switch. There's the phasing line, and that's how you hook it up. And it works really good. And there's the phasing line links, 22.5, 11 for 20. 7.615, and they all really performed well. I've done all these over the years. But you also can really do something special. You can build what we call the LC phaser. And the LC phaser is 2 turns of 2-inch coil, a 10-inch, a 10-position rotary switch, and a 3-position coax switch. And it allows you to adjust all of the phasing. And not only do you just do east to west, but you can really change it into things that aren't there and come alive. And that's what we call our LC phaser. And it worked really good. I use Ameritron's switch as well as DX Engineering. These things are enormous and they wire them in parallel. So I never have had in my, oh gosh, 15 years or more that I'm playing with these. I've never had a relay, either one malfunction, and it's great. What I don't like is the remote switch box. I hate rotary switches. So I go to Antique Electric Supply. You might want to write this down. This is one of the most interesting and greatest suppliers for ham radio. They have parts for days. Look it up, Antique Electric Supply. So I go out there and I bought some Les Paul guitar switches. And instead of that rotary, you can see I can switch to 75 east. I can switch it west, or I can switch to 40 meter east or west. And that carries on to my whole station. There's 35 relays behind me here. And it switches all the antennas. Then those colored ones switches the rigs. And there's a couple more of them doing other things on the other console. But there again, nothing like a resonant dipole. And I like coaxial dipoles. They really are something. In the late 30s, the government requested that MIT design and build a coaxial dipole. And they wanted it to be broadband, no tuner. And what they came up with was this antenna. I hear it miscalled and I get furious. It's not a bazooka. It is a very qualified, engineered coaxial dipole from the benches of Massachusetts Institute of Technology. No question, you will not need a tuner. And all of my dipoles, this is what I use for that system. Let's talk about that balun again. It's not a balum. Bob Heil goes ecstatic when I hear guys on the air talking about their balums. Did you not take the test? Did you not pass the test? Did you miss it about balance? It's balanced, BAL, to UN, unbalanced. Balun. That's what it is. And if you look at the drawing, what we're doing is we're taking a balanced line, and through a balun, we can make it go down one coax. And it's really a transformer. It keeps all of the feed line with the RF coming back down that feed line. It stops it. So the RF, if you have a proper balun, that RF does not come back down on your transmitter. And it really, really works great. When I was doing Ham Nation, we were doing all kinds of things. Here was a $2.45 75 meter dipole out of speaker wire. And I had a 50-cent connector, and then I got an old plastic top out of a entrance box, and that was it. Gosh, I worked all over the country. I worked some DX with that thing and 100 watts. It was great. I love having fun. This you kind of think could be a toy. It's not. It's great for portable use. These are yo-yos, and all you have to do, it's wire and just pull them out to the length that you need and different bands. And it's remarkable. And a lot of guys would make fun of it, but it's not. And all the POTA guys are starting to figure it out. There's a lot of other things that I've done over the years. Here's how to hang one up in the left corner. That's how to hang your antenna from a tower. Use a piece of aluminum or whatever. Works great. But I do not, down in the bottom, I do not recommend, and I want you to go home and take them all down. I want you to take off the pulleys. They're a joke. Well, I buy marine pulleys and aviation. I don't care what you buy. In snow and ice, they're going to pack up and you're done. So all of my life, I've been using carabiners, and it really works great. And the locking kind, that little red thing locks it up, and you just go at it. It works terrific. And up in the top right, that's a way I take a piece of plexiglass or fiberglass, and that's how I can make a cinder insulator. Down in the bottom's a little different, but same idea. But these are all things that we don't read a lot about, but we should. And the slopers really work nice if you've never tried them. One of my favorites is the one on the right up there, where I put a loading coil in it. I think it was on 75 and 40. It really worked great. And this one was very, very good. But slopers work terrific, and you get a lot of different functions from that. This one was very cool. The dipole just off your tower, get a low support on the standoff. But that worked really, really great. I had it up for a couple years playing around, and all of these were welcomed by me. A terrific antenna wire. It's from MFJ. You know, they built some outstanding products, and it's really sad that in the early days, Martin Jew made his way through college, building little simple things. And a lot of people, they kind of didn't understand what was going on. He had students that would wire the stuff and so on. They weren't engineers or anything. And so Martin really made his headway in the early days, but some of it wasn't as great a quality. Today, it is really super. It's engineered and it's great stuff, everything they're doing. And what you're seeing is this wire. I love this wire. It's 7 strands and copper coated and all that. And I love this stuff. First of all, you can't see it. And I have a situation here where this home we have in Belleville isn't to 5.5 acres. The only way I can do this is go across the street. A neighbor over there, her husband years ago, he's now deceased, was a ham before they moved here. And she allows me to borrow one of her 70-foot trees across the street. And then there's a guy behind me that's got a 70-foot tree. And that's what I do. And they work great. The situation is, see if you can see it. That's going across a major street. Nobody ever sees it. And it works great because it's full length. And it gets up about 66 foot. So there again, I'm in the ballpark to really take advantage of bringing the ground together. And that works terrific. There's the neighbor's house on the other side. I also have a Force 12 SS on top of the large garage here, and it really works great. And there's a 6-meter antenna that's no longer there. I took it down. It was a waste of time. And so we didn't worry about it. But I always wanted to get on 160 meters. I when we were in the Ozarks, yeah, I had 5.5 acres. It was great. And I got, oh my gosh, what are you going to do, Heil? I miss 160 meters. Well, one day about 2 years ago, Tim Duffy called me at DX Engineering. He said, "Hey, Heil, I got something for you." What you got? I got a 160-meter antenna that's 125 foot long, and it's not compromised. How can that be? 468 divide what? This is a new antenna. It was built in Germany, and it is amazing. Here's what it all looks like. You'll notice the two coiled wires, and it comes out of that coil and it goes into a little black coil and then into the balun and the feed point. Now, here's the deal. That copper looking wire, that's 125 feet. Well, now that's doesn't look like it. What is it going to be? What happened was, you see that black coil? There's about 60 feet of wire in there. And that makes up the rest of that antenna. And it's really hard to see here, but you can see it floating up in the air in those two little black coils. It's only 125 foot long, but that's made up of wire in this, which is stretched out, and that little coil wire. And there you can see it. It's right there. You can hardly see it again going across the street. I read a lot of things about antennas. I read a book one time from the Army. If you get out in a field and you need to communicate and there are no way to do that, put a nail in a tree. You're going to laugh at this, but it works. I've tried it. No, you're not going to work 150 miles, but you can get a good 4, 5, 10 miles if somebody's close. Try it sometime. It really works. It really does. Then comes my fave, indoor antennas. But these are ones that really work. Jim, AC0KN in Kansas City, good friend. He wanted to build an attic antenna, but he just didn't want a regular 2-band fan. So he did 10-band attic fan dipole, 80 to 2 meters. Here's how he did it. He works DX like crazy every day from his attic. First of all, he takes a balun and he does all of these down the side. Those are all backed up with aluminum, so they're all shorted together. And they feed different wires coming out of there at different lengths. He cut them all the length from 75 out to the 2 meters. And it just really is fascinating. Works great. Here's a little better view of it. And for all you doom and gloomers, well, that can't work. Well, yeah, look at this. I only did 40 meters. Look at it. 75, 20, they're all like that because he cut them. But over on the right, that was he owned the Fugly was 6 meters and 2 meters. But he only wanted them for a repeater. So we cut it for a repeater. It works great. This is good stuff. And then from W9BS, I read this on the internet. His attic antenna exceeded my expectations for RHF, he said. I've worked way more DX than I ever thought possible with this attic antenna. The key making the antenna work on all bands is the tuner and feeding the attic dipole with open wire or balanced feeders instead of coax. And so that's what he did. It's got north and south. There's 25 feet, then a leg of 23 feet, This is all nailed up in his attic. Then he comes back 25 again. And that's the feed point. We'll come back to that. Then he's got 25. He's got over here 23. And then he's got 25. What does he do at the feed point? He does open wire. Typical, right? I despise open wire. It is absolutely a joke. And you're going to say, well, Heil, you're crazy. What are you going to do instead of that? I love balanced feeders, but not that way, because they get all tangled up in the wind and the snow gets on your wire and you're done. Why has somebody not thought of better? Well, they have. Check this out. This comes from one of my good buddies who is now deceased and in Kansas City. Look what he did. You take a pair of, it could be anything, any kind of coax, and you strip the outer black off so that you can short solder together the two coaxes. And of course, what comes out the end goes to your antenna. Down at the bottom, you do the same. This is in your house. You solder the two shields together and you go into a balun. And then you ground that properly. And now you have a wonderful, wonderful operating open wire feeder, and you never have to worry about weather again. It's really incredible. Why do we not read about these things? I don't understand it. It makes me really mad. This is why I put together these things to let you know these are not something I just dream up. I read about. I try them over my 67 years. I put this stuff up. I love this kind of stuff. When I was on the West Coast, we lived out there for 5 or 6 years on and off, working in the studio. So you don't have much up there. So what I did is I used a balcony and on the condo, and it really worked great because what that did was it gave me a place to mount one of my Hustler mobile antennas. And you would be surprised how well that worked. I had schedules with the guys back in Illinois every day at noon. And all I had was one of those 40-meter Hustlers. No, I wasn't 30 over 9, but I was usually somewhere S7 to S9. And slinkies, man, slinkies work. If you never tried it, do it. Of course, you got to pull it to length and all that. And it just works great. And then here's another. If you've never tried a fence, oh man, the fence antenna works terrific. And again, the key is a good tuner if you're doing some of these things. You also can shunt your tower down here. That works great. And yes, I've done it to trees. Why not? But the fan dipole in all these configurations, it works very, very well. And one-to-one balun and all of that we went through a while ago. But the situation is that you just don't want to be afraid to try anything. I think that's one of the biggest fallacies of antennas is that people have heard, well, that won't work. Try it. You would be surprised. And it's not only just, antennas, it's everything. So give it a try. And then we get into our popular subject of SWR. This drives me freaky crazy because I hear guys all the time. I listen a lot all day. I'm here in my lab and I'm listening, and these guys, oh my God, my SWR, oh my God, it's 1 to 1.4. I got to get off the air. Why? Well, I'll blow up my transmitter. And it's like, where are you learning this? disinformation. SWR has nothing to do with how well your antenna works. I'll tell you that right now. It's a measurement of how close the antenna is to the desired impedance of your transmitter. That's all it is. Standing wave ratio. When I built this new studio, there is no standing waves in here. And you're going to go, what? I don't see any wires. No, audio has the same deal. There are no parallel walls in this studio. The roof is pitched by 4 degrees. I had one stinker of a time trying to get the contractor to do, wow, it's got to be level. I said, no, none of it does. Because here's what happens. And now think about this. If you go into a theater, have you ever seen parallel walls? No, you haven't. Here's why. When sound comes to you, comes to your ears, don't feel that it stops, because it goes on and hits a wall in the back. If that wall is parallel, they're going to come right back to you and cause the most ridiculous sound ever. It's going to be out of phase. It's going to sound weird. But if that wall back here is tilted, when the sound passes by you and hits that wall, it's going to go somewhere else, not back to your ears. That's exactly what we want to do with RF. We want to make sure it doesn't come back down into your antenna feed line. And it's a pretty simple thing, but I don't ever read about it. And I love doing these things because I think it helps a lot of people. These aren't things that Bob Heil thought up. These are pieces of science that's been around for a long time. A man that was a very religious man who owned Crown amplifiers. Mr. Moore had several mega stations on shortwave, and he was transmitting the gospel down into South America. But he was running so much power. We're talking half a kilowatt. No, we're talking 500,000 watts. And he was burning the end of the antennas off. So he figured a way and came up with a new concept, and it was called, look at that. That was his cubical quad. And it really plays. It's a stinker to keep up sometimes, especially in weather. But oh man, does that thing work? And that's what he used on his shortwave stations. And you go look some of this up. This is all great history. And of course, don't forget the balun. Yeah. And then how do you bring coax into your room? I did it with toilet flanges. On the subfloor, I mounted a toilet flange. And then we bring the coaxes in. There's somewhere around 30 coaxes, 15 on each side here, that run out 500 feet to the phased arrays. And that works really good. And why not? Because there's a lot of times that you don't have a good way to do it. I was just testing all this. The relays came later, of course, but these things work really good, and the toilet flanges. But there again, you have to think about what's going on. And then what about the SO239? You read it in the books about how you can do these coax connectors. And you go in and you have to trim off some of it, and you do the center, and then you got to solder through those holes, right? Well, I'm here to tell you that whether you agree with me or not, I've done a lot of studies with some of my buddies about this. You cannot verify that all of those shields are soldered. So what do? Well, it's real simple. When I first got into this, I was 15 years old. And one of my great mentors I met on the air was the chief engineer at KMOX radio in St. Louis. And I started going to his house at night after I played the theater organ and on the way home. That transmitter right there, I built. It's a Central Electronics 20A. And from that, Larry Burroughs taught me how to build one of the first 10 single sideband transmitters on 6 meters. He had one of the first. And I learned so much from him. And one day I took a piece of coax over to him and I said, I'm having a tough time soldering this. He said, what are you doing, kid? You're trying to solder through those holes? Well, that's the way the handbook. I don't care what the handbook says. You can't do it. Well, then what do you do? How do you do that? So here's what you do. You go out, you cut the black insulation off for about a half an inch, fold it back, insert the center conductor and solder it. You know that's soldered. Then you come back. I took a piece of industrial scissors and I cut all of those shields off and soldered them. Now, before you do this, you want to solder around all of that. It's going to get real hot. So put it in a vise and really get that juiced up. You come back in about 20 minutes, it won't be all hot to go. And that's how you do a coax connector 100%. You want to argue with it? Fine, but you're wrong. You cannot do that when you're pushing it through the hole. And you can do the same thing for the RG58. I always used to tape them up because my friends would come over and make fun of me. What are you doing, Heil? And I quit telling them. So I just went on my way until about in 2016. I visited my great friend, contest guru, Tim Duffy. An amazing place. Look up his look up him YouTube's on this place. 11 monster stations. He's built all the amplifiers. They're all the same 7851s and just an unbelievable amount of antennas from 300 foot to whatever. And I walk in and I'm looking around and I look in the corner and here's this bundle of coaxes coming in. And I look over at one of them and I'm going, wait a minute. One of them was done like that. I went over and shook his hand vigorously. I guess he figured, what's wrong with you, kid? I said, and I told him his story. He said, oh, no, you don't do that through the holes. This is how the professionals do coax connectors. And so he kind of, got me in the right place. I forgot to show you the end of the entrance of the toilet flanges. That's the way they all worked out. And it just works great. I got them in this room and had them in several other homes. But it's all about sharing some of this great technology. And there's just so much more. This is hard to see, but there's these stations behind me. What you see there, that's the single sideband console. That's over my shoulder. That's these one right here. See, I work for ICOM. I work for Yaesu. I work for Ken. I designed the equalizers in all their radios in 2000. We started about 2001 with ICOM. Those are all my equalizers, and it really changed ham radio because we do need equalization and proper microphones, and that's what we're doing. But when I look at all of this, you can see that all of this is done with the relays. Down at the bottom we bring in all the antennas, and then the tuner or the switcher is there and allows you to switch which radio you're going to do. But then out of that, it goes into a transmitter selector. And these are all done with these. I showed these in the boxes, but they're all done with these switches behind me. I'll show you in a minute. But that allows you to take all the transmitters into a 922 into the scope. Everybody needs a scope. And the Daiwa, that's a peak reading watt meter. Then it either goes straight out the antennas, or I switch it off to the other side. And the other side meaning that desk. And that's all of the vintage stuff. And so from there, why, it's the same deal, but I can switch that whole array of antennas over to that side. And then we can control that just like we did the others. And it really, really plays. I am really so happy. There's the vintage stuff. And same deal. We come out of the antennas and see that switch box. And those antennas are really getting it from the other transmission of other console. But then it's pretty much basically the same. Only here it's all a lot of dial key relays and modulators, and this is all tube stuff. And then down at the bottom, the microphones plug into a parametric equalizer. It's a broadcast strip. It's the Symmetrics 528E, and I have a panel that I wonder if you can see that. I hope. Yeah. Right there. Just like the old telephone operators, and I select which transmitter the microphones are going to go to after the equalization. And this is really fun stuff. And it really coordinates your station. A lot of people, talked to a guy this morning, he had things so rigged up and half of it didn't work. But this really augments all of that. And I love doing it because a lot of guys, they kind of back out from there. But you can do it very easily. There you see some more of the switching, and the antennas are all, and the Les Paul guitar switches, and the colored ones are switching the other things. If you don't have this, I really invite you to go to our website. Dealers have them also, but this handbook I wrote some years back, and it's got even more than what we're talking about here. And then it gets into all of other kinds of things too. Pick that up. If you call into the plan, I'll autograph it for you. It's a worthwhile piece, let me tell you, because you don't read stuff like this. The stuff that we read today is all about stuff we don't really need to know. But get into a lot of cartoons and stuff to make it. But some of the stuff we talked about and many of the things that we didn't. And then we get into audio, and we get into how to adjust audio and microphones and how to build and all that. And it really helped a lot of people, and we're still writing. And if you go to the website, heilhamradio.com, if you go to that website, you can download this free. It all starts with the microphone, and it's very, very educational for you. But I'm very blessed and honored that a few years back, Heil Sound was inducted into the Rock and Roll Hall of Fame with many of our touring products, the mixers and speakers and amplifiers and microphones and things like that. And we're the only manufacturer in the Rock and Roll Hall of Fame. I'm very blessed by that. That mixer that I'm standing in front of is a mixer that I built with one of my English compatriots. That was the Quadrophenia mixer. It's the only quad mixer that was built. Down on the bottom on the right, a ZZ Top's mixer, the famous Heil talk box that Peter Frampton and Joe Walsh and I built. Nice picture of Jeff Beck. We were the first people to do monitors. And you're going to ask, well, why? Well, when I got into this in 1967, there were no monitors, because monitors are something, with the bigger the PA, the less you hear it. You, the artist, hear it on stage. Because if it's too loud, it starts feeding back, right? Well, I figured it out. How'd I do it? One of the other hundreds of times that ham radio came into the rock and roll stages, I wired the thing out of phase. Yeah, the monitor is out of phase. Guess what happens? You just heard it a while ago. It didn't feed back. And I really did that with the Grateful Dead. Garcia wanted some monitors, and we did it with 2 microphones first. And I said, you know what? We could do that at the amplifier and speaker, and that's what we do today. It's a given thing. But those are things that over my life, ham radio has had so much to do, because I learned it all from here. And I was very honored by that. And then a short time later, I was issued a PhD by Missouri University for music and technology. I barely made it through high school. I was too busy working. I was making more money than my teachers, playing the Wurlitzers and all the big organs in the theaters back in the 50s and 60s. I didn't need all of that. I barely made it. My grades were D's and F's, but I think in gracious, they just let me go. But I learned so much from ham radio, and that was the big key for me. Well, you should have some questions for me before we head out the door. Don't be shy. What you got?
Anybody have any questions, please unmute and feel free to ask.
No.
Well, this is off your main topic, but you said that we should all have oscilloscopes. And how
Yes.
do you use your oscilloscope with ham radio?
Oh my goodness. You're going to go buy them for $30 usually. And these are $2,000 thingies, right? And I don't have a diagram just right here with me, but I think I can show you what it takes. Oh, you know what? I do have. Hang on. Where is it? There it is. There it is. Yeah. My savior for you, man. Okay. Here's what you do. I guess I should put that in here. What you do is you run a straight wire, coax to coax. You come out of your transmitter into the oscilloscope, out of the oscilloscope, and here I can show you real easy like this. You come out of the oscilloscope into the, I always want a peak reading watt meter, and then on out to the antenna. See that? That's what you do with it, because then you can see if you're distorted, if you're overmodulated, if you got some kind of crummy signal, it's raspy or whatever. It's amazing, and it's very simple in its design. And I should put that up here. Email me and I'll send it to you. Why do I want a peak reading watt meter? I'm going to give you a piece of advice that you won't believe. You're going to get on the air tonight and they're going to say, oh, Heil's full of crap. Well, I only follow science. Okay? So if you want to call it what you want, here's the deal. I hear people all the time. They get their 7,300 or whatever, and they try to make it 100 watts on that meter of that transmitter. I'm running 100 watts. Well, when you do, you're splattering all the hell up across the band. You don't know it maybe, but you are. You're splattering. Here's the reason. You never want to see more than 30 or 40 watts on the meter of your transmitter. How many times am I going to get blown away tonight on the airwaves and people, he is absolutely crazy? No, because here's why. What you see on your meter of your transmitter, no matter what it is not peak reading. And that reading you see, you actually are 4 times that. You are actually doing 4 times what that meter is reading. Now, with a peak watt meter, that 30 watts will be a little bit over 100. Don't believe me? Do it. Get you, you see it right above my head, right there. That is a mainstay in my stations because I want to look at the peak reading. And that's how you use it. And you want to get into the scopes and you want to look really hard at how you can hook those up. And you see I got 2 scopes. I have one down below here. That's on the Central Electronics. It's a piece that Central Electronics built. So that and the VFO and the transmitter. But then I have a Kenwood up here that's looking at the ICO and the Harvey Wells and all the other transmitters, but that's all AM stuff. Now the 20A can be on sideband, but I use it for AM. But I thank you for asking that question. Please send me a picture. I need to put that in my presentation. I have it in other presentations, but it's real simple to build. And what's really crazy about it, I have a headphone out with a diode, and for AM, I can monitor what my signal sounds like. And it really, really, really plays for me. And it probably costs $5. Did that help you?
Yes, thank you very much.
Yeah. Any questions? Come to me. Anybody else? Nobody?
Can you email a diagram of that circuit so I can pass it out to everybody?
Sure.
Yeah, just send me and I'll forward it out to everybody.
Yeah. I'll get you a couple of them. Okay.
Okay.
Yeah. Okay.
Any other questions, guys? Was your organ working this month?
No, I've got some things disconnected here because we're reevaluating some of the speakers up above me. And it's not working. I'm sorry. It works, but it won't make any noise.
We already had that demonstration.
Yeah.
Question I actually have on the sound. You're talking about the uneven wall. I understand, or unparalleled wall. That makes perfect sense to me. What do you think of course, not all of us can move our walls in our house.
No.
So what do you think of the foam stuff that goes on the wall to kill the sound and echoes?
Oh, it helped. You're talking about the convoluted foam. It's
Yeah.
not just a piece of foam.
Yeah, no, the convoluted with the.
Yeah. Well, let me tell you what works just as good. And I over my life, I've spent a lot of time building theaters. We were in the home theater business. Now, we're not talking about little things at Best Buy. We're talking $200, $300, $400,000 rooms for people that could afford them. It was fun for me because it was all very high end stuff and motorized curtains and real theater seats and all that, and high definition back in 19, started in, where was that? 79. We had high def. You had to get out your pocketbook and you used laser disc, but that was a big thing. But all those rooms are all different dimensions, and you can make them really pretty. One of the things that I did to a lot of my rooms was I didn't use the foam, I used carpet, the cheapest carpet. So it's got a, it's not real coarse. We want it to soak up the sound, and we could do a red bottom and come along with a blue thing. And that really worked great because we could do patterns, and the rock people would come in, and just like they're doing it on the floor, they do it on the walls. That's what's in this room. And yeah, you can see some of that back there. It's a stiff carpet, and it works really good. But yeah, play with some of that. You can you'll be surprised what you can do by creating a good sound force.
Okay, thank you very much.
Sure.
I have a quick question. Well, Bob, first of all, I'm a new ham. I really appreciate you sharing all of this information. And I'm not sure I know enough to have a good question, but I was wondering, Greg, is the recording going to be available so that we can?
Yes, I will post it online.
Yeah.
The group
Greg,
video.
Great.
Patricia, just remember something that I was told in my first few weeks as a ham in 1956 from a great mentor. No questions dumb the first time. Okay.
Thank you.
Yeah.
Well,
sometimes we got to go back and revisit it, but it's all fun, and we're not getting enough of this. And I blame the league. They're out there way on a pendulum, and we're not third degree engineers, and they want to keep pushing that. They need to get back to what we did tonight. There's not enough of that. Maybe I'm totally wrong, and please tell me if I am. But I just hate it because a lot of young people are forced out of the hobby because they think it's too much for them. No, it's never too much. And every day I learn something more. I really do. So thanks for that question. And
Yeah,
any of you, if you have a question, email me. I get sometimes 40, 50 a day. Sometimes I get 80 or 90, and I answer them all. And I love sharing this hobby. So don't be shy. Send me an email. It's really simple. My call at ARRL gets it. Look up my QRZ page. There's a lot of stuff on there too that you might want to look at.
Could you give us your URL again for your website?
Oh, it's real easy. It's Heil Ham Radio.
Oh, I might be able to remember that.
Let me see if I can.
Thank you.
Over here, I got a question on receiving.
Yeah.
What kind of speaker do you recommend?
Well, I am very partial to JBL. I have from all the many decades I was out on the road. There's nothing like JBL. And you can get in some really serious arguments. But there's only one problem. Ignorance causes a lot of arguments. Trust me. JBL, you go out on the concert blocks today or this studio, walk into a $5 million studio and tell me what kind of speakers they have. Most of it's JBL. And I love them. Let me see here. Oh, hang on. Hang on. Hang on. I use a whole bunch of these. They're called Control 5s, and it's great. It's heavy, got a huge heavy magnet, and then it's got a titanium tweeter. They even make one that's got a 100-watt amplifier in it, but I don't use that because I just use these to be driven by my receivers. It's very efficient. It only takes 1 or 2 watts to really make it go. So JBL, check it out. And I just like the Control 1s. They make Control 5s, but look through their stuff. You'll love it. Yeah, thanks.
Anybody else?
Well, I hope that this was a little bit of a learning for everybody. If you just picked up one thing, that'd be good. But I'm always here. I am always here. All you got to do, send me an email and I'll be here to help you. And I'm constantly at it, I'll tell you. I love this hobby.
Well, Bob, thank you very much for joining us again this evening. And thanks for it. And I agree with you. The ARL is trying to take amateur out of amateur.
Yeah.
And stuff. So I like it and I appreciate it and stuff. So thank you very much for joining us again this evening.
Yes, well, that's what clubs are about, to take the good stuff and pass it on. And that's what I've done. This is number 330, I think I've done since 2020. When the pandemic started, I used to go to club meetings. I mean, we could get in an airplane and fly all over the country for next to nothing out of St. Louis. Not anymore. And I thought, what am I going to do? Shut everything down. I started doing these Zooms. Hey, this is better than being there with you because I got toys. I got things I can show you. And it's a blessing to me because I get to bring you this information that I think is really important. And you're going to find a lot of people. You're going to go on the air tonight. There are going to be a lot of people that they disagree. But you know what? They really should take a listen. We can all learn from, because it's science. It's not Bob Heil. And I love digging more. So we'll come back. I don't know what we talk about next time. I don't know. We'll come up with something, but thanks for having me, Greg. Greetings to all of you. And please send me some emails. Bye-bye for now.
All right. Thank you very much. Have a good evening.